All right. Hello, everybody. Thank you so much for joining us tonight. Welcome to our February Data Science Code Pudding live stream. My name is Tiffany Hall, and I'm an alumni of TripleTen Software Engineering Program. So, naturally, a full stack engineer. Also, a product owner at Scholastic, the world's largest publisher of children's books and a powerhouse in the digital education space as well. Tonight is one of my favorite things I get to do, which is to host all of our code jams and code puddings. Tonight's event is the TripleTen Data Science Code Pudding. So many of our students could join today, so that's very exciting. And I'm very excited that I get to see all the people that show up on the live chat. So make sure you are there so you can shout out your favorite group. All right, so if you're new and you're not quite sure what a code jam or a code pudding is, let me kind of work through what that looks like for you. All right, so at TripleTen, we like to have these competitions that put our students in groups, teams, during their normal coursework. They're super short competitions. We're talking 4 and 5 days, very short. The students get together and they are either jamming out a bunch of code or they're putting in the work. Pudding, like pudding. It's the dessert. Okay, well, so our pudding consists of two parts. Our pudding has a working with data part and the building of the model, those things, and then the presentation. That's where we are here tonight. So the presentation is going to cover all of the things that our teams have done over this last week. Our participants were divided into teams, and we challenged them to collaboratively scrape all of these movies and actors and things and putting it all together. It is going to be fascinating to see what they come up with and how their data brains work. Teams only had 5 days to complete all of their projects, so it is going to be an amazing amount of work in a short amount of time. The teams are going to show off all their projects tonight, and then we will tally up audience votes. The audience votes are going to come from our YouTube channel, which is going on right now. And if you want to put a thing in the live chat saying which team you want to vote for, then we'll make sure to count those votes. If you're a student of ours, then you will be able to vote on your favorite team in our Discord channel. Okay? So the judges will then spend the next week evaluating both the model and the presentation. And then we will post our results on our Discord and our socials on February 19th. So if there are any concerns about making sure your vote gets counted for your favorite team, please make sure to put it again either in the chat if you're not a student of ours yet, or in the Discord if you are a student of ours. All right, now let's start with the fun part. The fun part is getting to talk to the teams. We have 3 teams tonight, and so the first team we're going to start off with is Monty's Data Circus. And that team consists of Deborah Thomas, Leah Wexler, Daniel Huntington, and Alfonso Houston. Go ahead and take it away, Monty's Data Circus.
So, hello. Can everyone hear me?
Loud and clear, you're good to go.
Okay, all right. So this is our presentation. Um, these are all the names of the individuals that are within our group. Just go ahead and start. So the mission for this project or the co-putting was to scrape, IMD website for movies and aggregator, and just perform a brief EDA on it, or exploratory data analysis. Just hand this off to. Okay, so the IMDb web scraper used Selenium and Beautiful Soup, which is brought to you by our team. The project consisted of scraping the top 250 movies from the IMDb webpage, and we just sought out to answer 3 questions. First one is there a relationship between movie duration and release year? Second, is there a correlation between Oscar or movies with Oscar nominations and movies with Oscar won versus and popularity score? And the last question we want to basically see was what is the distribution of rating class by genre? Okay. So scraping, so basically we started off with scraping the top 250. We extracted a list of the top 250 movies. Get we basically gather the additional attributes about each of these movies, and then we dug deeper and collected more information on the actors using the same movies and their details as a reference, and we just did a data analysis and cover these three questions. So
All right,
here's
so I'll take it over from here. So first we're going to talk about winning with web scraping. If you can press the next slide, Alfonso, that'd be great. Okay, so to keep our IMDb data up to date, we built the web scraper in two parts, one for movies and one for actors. On this slide here, you're seeing how we handled the top 250 movies. To start, we needed a way to scrape those movies, and that's what you see on this page. That's what we were looking for. Initially, we tried using only beautiful soup, but we ran into gaps in the data. Some things weren't loading correctly. We weren't getting the years or the movie duration. So how long is that movie? So we switched to Selenium, which let us open a browser window and fully load the page before scraping. The process was pretty simple. We pulled the movie details, we stored them in a list of dictionaries, and then we converted that into a pandas data frame, which gave us a structured data set of all 250 movies. Our teammate Daniel, who's not here today, we miss you. Hi, Daniel. Handled parsing the JSON data from that we did for our initial parse with Beautiful Soup, and then we integrated that with My Beautiful Soup work. We did most of this over Google Colab, and we tried to collaborate wherever possible. We ran into a couple of hiccups with Selenium and Google Colab, which is a story for another day, but let's get on with the data. So if you can press the next slide. Awesome. So here we are, movie details. What are the movie details that we were picking up? We started with that list of the 250 movies. Excuse me. And we used the movie URLs from our data frame to visit each individual movie page and extract the data we were looking for. The process was kind of like assembling with Legos. Each small piece represented a small movie metric, and like finding the first three stars, which you see highlighted here, like Michael J. Fox, Christopher Lloyd, Leah Thompson. To keep things more manageable, we wrote the scraper in a really modular way with built-in testing blocks for easy debugging. By solving one small piece at a time, we were able to build a much larger, much more reliable system and a more robust one. At first, when we ran this through Selenium, the process was really slow and very error-prone, but after refining our approach, we optimized it to visit all 250 web pages and generate a pretty clean CSV file in just a couple of minutes. Far better than the half hour it took the first time I did this, which was pretty painful. We also ended up in that first painful experience with data overlapping when web pages logged while loading. You can press the next slide. Thanks.
Okay.
Awesome. All right. So for the actors, so for part two of this web scraping process, after collecting the movie details, we shifted our focus to the actors. For this, we used entirely Beautiful Soup to scrape the actor pages linked from those movie URLs we had gathered. From our list of 750 actors, we removed the duplicates and accessed 649 actor pages and 649 of their awards pages to get the data we were looking for. To handle this efficiently, our script processes actors in batches of 100, saving each batch as a CSV file and saving corresponding data frames. This made it much easier to approach managing and handling large sets of data without overwhelming our system resources, my computer, or getting me blocked by IMDb, which definitely happened a few times. And it required me to come up with some stealth mode tactics. What stands out about this work was the way that we built the scraper. It's really easy to expand. If we ever needed to grab additional details like box office data, which was a bit beyond the time frame we had here, you could easily do that. You could easily test it, and it works without rewriting everything we did. The modular structure also helps debug, and I think actually it also helped improve our skills. Instead of writing one long linear script like I tend to do as a beginner, it forced me to learn how to break things into smaller testable components. It made it easier to rewrite and explain and help work with and collaborate with the team so that they could jump in and contribute. Thanks, Fonz, for teaching me about dependencies.
Next slide. So we're going to enter the data analysis portion of the project. Deb?
Hi. So I answered question 1. Is there a relationship between movie duration and release year? And as you can see from the graph, it's pretty easy to read. 1924 is the year with the shortest movie duration. 1978 is the year with the longest movie duration. And so we thought, what would happen if we looked by decade? So looking by decade, the 1920s was the decade with the shortest duration, and the 1960s was the decade with the longest movie duration. And keep in mind this, we only scraped the top 250 movies. So this is what we got looking at that data. Back to you, Fonz.
Okay. On to the next question. Second question is there a correlation between movies with Oscar nominations and popularity score and movies with Oscar wins and popularity score? It's a little animation right here. Okay, so to depict this, we use a line graph, and represented on the x-axis is the number of Oscars, on the y, the average popularity score. And as you can see, the black line is movies with Oscar nominations, and the gold line is movies with Oscar wins. So with the gold line, the average popularity scores decline for movies that have between 1 to 5 Oscar winnings before sharply increasing with for those with more than 5. And a similar trend also occurs with Oscar nominations, where the scores between, the scores drop for 1 to 4 nominations and rise significantly after hitting 5. So on to our last question. This is basically just seeing what genres compose a rating class. So the whole circle right here, this pie chart, is the G rating class, and the little slices represent each genre within that class. And here you can see that the three major genres that are depicted here are adventure, comedy, well, actually 4: adventure, comedy, animation, and drama. And it's not included in here, but we did in our code a little descriptive statistics just to see how the distribution of rating classes were, and both of them follow a right skew distribution, which is essentially when majority of the data points or movies are clustered towards the lower end, with a few high value outliers, which is seen here with these 4 right here, and then you kind of have these smaller slices. Same thing goes for here, but for the PG rated movies, you can see here that the distribution is more pronounced here, with more smaller slices towards one end, and then big outliers here. And we did a little bit of a comparative analysis between the two classes. Yes, they follow the same distribution, but when it comes to the top four genres, they rank differently in those, and you can see that on the slide. All right, so it's all right. It's to conclude, this is hand off to Deb.
So to sum up the questions, is there a relationship between movie duration and release year? And there's just a slight upward trend going from movies from 1921 to 1978. So it's not a very strong correlation. And again, the year with the shortest movie duration is 1924. The year with the longest is 1978. And again, when only looking by decade, 1920s is the decade with the shortest movie duration, and 1960s is the decade with the longest movie duration. Question number two, is there a correlation between Oscars nominated, Oscars won, and popularity score? And this was pretty interesting. You would think there'd be a direct correlation, but it seemed like there was not. Average popularity scores decline for movies winning 1 to 5 Oscars before sharply increasing for those with more than 5. A similar trend occurs with nominations, where scores drop for 1 to 4 nominations and rise significantly for 5 or more. Oscar nominations seem to affect movies' popularity more than Oscar wins. This strongly suggests that the winning or nomination of Oscars doesn't dramatically affect the popularity of a movie until a movie has been nominated for at least 5 Oscars or has won at least 6 Oscars. And question number 3, the comparison between rated G and rated PG movies. 69% of rated G movies fall into drama, adventure, comedy, animation. And as for PG, animation, drama, adventure. The rated G discrete discrimination is positively skewed, as Fons showed us, and it is also positively skewed for the rated PG movies. Because of the skewed nature present within the data rating distributions, this affects the likelihood of viewers encountering specific genres when searching for top-rated movies.
And that basically concludes our presentation.
To be continued. All right. That was great. I really enjoy the themes that you guys carried through. The movie theme was really great. So kudos on that. Let's ask some questions. So you guys said there were some challenges with selenium. Maybe you could explain for our viewers at home what selenium is and tell us a little bit about those challenges so that we can all grow and learn from each other.
Sure. So Selenium allows you to open up a web browser on your computer. It kind of makes a fake web browser. The challenges with it is that you're making a fake web browser. And as we know, most websites don't like robots. If you've ever filled out a CAPTCHA, or if you've ever had to guess how many sidewalks that actually was on a picture, you have fought the robots.
Yeah.
When you're using that in this context, it's kind of a similar situation. You're making sure that not only your environment, meaning your computer, is set up to work properly with this, you're also making sure that the code that works will work on somebody else's computer with their own unique settings. So part of the challenge of working with Selenium and sharing the code, not just running it for yourself, is trying to make all of those pieces and parts play together. And I think that just adds a level of complexity when you're trying to scrape web data, but scraping the web data is, depending on how you did it, you could have been looking at an XPath, you could have been looking at CSS to figure out those elements, and then maybe you're using a regular expression to pull out the piece of text and then turn that into a number. That's a lot of stuff going on. That's a lot of pieces and parts.
Mhm.
So it just made it that much harder. And Colab was a challenge. I just have to leave for another day, trying to make it so it could be a really, truly collaborative coding environment and use paired programming or another method. Just felt like in 4 days, that was a bit too much to handle. So.
Yeah, sure. The time crunch is so real. That is for sure. Thank you so much for explaining that. I think you have definitely highlighted a lot of challenges that we face when trying to do kind of the, like you said, the web scraping, but which is one skill set, and then setting up Selenium is a whole different skill set. Um, so let's talk about like data cleaning. You guys got a lot of data. Obviously, you guys have movie times, run times, and you went through all of the Oscar nominations. What kind of data cleaning did you guys have to do from that scrape to get it into something you guys could use?
I cleaned the data, and I think Leah must have cleaned it a little bit before it was passed on to me. So when I got it, of all the columns, there was just, I think, just 5 non in, I think it was the rating column. So
Okay.
just, it was pretty light cleaning, really.
All right. Well, that's good to hear. At least a little bit of an easy process there. All right. And then just kind of last question, like what was the thought process you guys had in trying to pull out the questions you pulled out, right? Because I know that we're going to see all of the different projects tonight, and every team is going to have a different set of questions. And so I'm just curious how you guys landed on these three.
Oh, I can speak to that. But originally in the beginning, we all decided that four of us was going to come up with three questions and then meet. Um, and we just shared our questions and we kind of bounced it off each other and kind of decided on the three. We didn't want I guess surface level questions. We wanted ones that were going to require a little bit more thinking, a little bit more analysis, and kind of stand out from just a typical just a typical question, if that makes sense. So it was
Yeah.
more or less just kind of just bouncing our ideas off each other and just seeking feedback, if that makes sense.
No, I think that's great. Yeah. Yeah, and I like the questions that you guys came up with. I want you to know that I was there in 1924 when they showed that first movie. It was very short. My popcorn wasn't even cold by the time I got out. So, okay. Well, thank you guys very much for your time tonight. That is our very wonderful team of the Monty. Oh, hold on one second. I lost my thing. Here we go. The Monty's Data Circus. There we go. And that team is Deborah Thomas, Leah Wexler, Daniel Huntington, and Alfonso Houston. Thank you guys very much for your presentation. We're going to go on to our next team, which is the Fuzzy Pandas. And the Fuzzy Pandas, I love these team names every time I do these things. The Fuzzy Pandas is Anthony Johnson, Ryan Modesset, Phil Zamazahir, and Robin Matthews.
Hello, can you hear me?
Oh, I can hear you.
Yes, I'll be doing the first thing. Robin Matthews. I'm part of the TripleTen's data science course. I'll be doing the web scraping part of this. I don't know if my screen is up or not.
I don't see it. I'm staring at Deborah's doggy.
One second, let me see if I can.
Hey, there we go. All right, we can see your screen, Robin.
All right. All right, so first we use Pandas, NumPy, and import request and beautiful soup for most of our environments. For the data part, collection part, I had real difficulty trying to get the data from IBM DB or IMDB. At first, when I tried to get the data, it would send me like the data frame would have no columns in it. So I would literally just have nothing to work off of. for hours I worked at different angles trying to get the data from it. And then I realized back in some of our other like sprints that you can use an API key to be able to gain access to their information. And that's here. I wasn't for sure actually how to use the AP key at first. I had to go back through some materials, like, and it just was easy enough. You just put it as a pretty much give it a column by itself, pretty much. And then when I did it that way, I still wasn't coming up with all the data. Like I would come up with the actors, and then it wouldn't give me any of the other information. So I did a bunch of error, like if it ran into an error to do specific things with it. And then I appended the data that I wanted, like the titles and title area and year, so they were in the right columns. And then down here, if any of those errors were to pop up, it would like let me know why these errors happen. And then I moved it into a data frame. To get the movies I wanted, I actually chose out the 100 movies by myself. Like I picked them all out, the top 100. That's all these here. And then up here, it'll go and find all these movies and all the information for these movies. I didn't run it. That's why it's not displaying anything here down at the bottom, because it takes a minute for it to try to go and get all this information. So it took longer than this presentation would have been, pretty much. But you can see it later here on data cleanup. When we get to it, you can kind of see my all my information. And then I saved it into a data frame, and then that's when we pass it over to Ryan, where he'll do the data cleanup and visualization.
Yep, sounds good. If you don't mind, Robin, I'm going to share my screen so I can kind of scroll up and down where I need to scroll, if that's cool.
That's fine. Do I stop sharing mine? There we go.
Thank you. Okay, cool. All right, so Robin just went through the web scraping portion, what he did to be able to extract the data from the IMDb website. Next step
Hey,
was
Ryan.
to, oh,
I'm sorry to interrupt you in the middle of your flow. Could you zoom in a little bit? Some of our YouTube viewers are having a hard time seeing. Yeah,
that may be a little better.
much better. Thank you.
Okay, thanks. Yep, so Robin just went through the web scraping portion of the project, which was extracting the data from that web scraping tool that he created, which got the data that we needed to do some data analysis. Before we did any analysis, though, we needed to clean up the data a little bit, and I'm not going to dive into each cleanup task that we did. That would take a while, but I will pinpoint a few of the important ones. We were talking about what we wanted to analyze. IMDb ratings and popularity often came up, so we made sure that we removed any records that didn't have any IMDb ratings, that had missing values. We didn't want those to be a part of the analysis because they weren't relevant. We didn't want to consider those. We also made sure that we dropped any duplicates because we only wanted to analyze each movie once. And then out of that top 100, that list, movie titles list, if I scroll up out of this 150 movies or so, we only wanted to look at the top 100 in terms of IMDb rating. So after doing all those steps, this is what the final data frame looks like. Much more neat and easy to interpret and read than a JSON file. That is what came from that web scraping tool at first. And at this point, we can now do some analysis from here with this data frame. So that was the movies data frame. We also had to create an actors data frame so we can do some analysis around actors. And to do that, we actually started with the movies data frame to get the list of actor names as well as the number of films that each actor appeared in. And one important point about the actors data frame here is if we go up above here, you can see that if we take a look at the first record in the actors column, we have multiple entries or multiple actors for this record: Tim Robbins, Morgan Freeman, and Bob Gunton. So to do the analysis we wanted to do, we had to basically blow this out. So each actor was its own individual value. And we did that through the string split and explode methods. And after doing some counts and merging of a few tables, I'll skip a few steps there. This is what the final actors data frame look like. We have actors, which is the actor name, and then count, which represents the number of films that actor appeared in. So after the cleanup, after both data frames were created and cleaned up, we then are now going to the data analysis portion. And we were really concerned with, again, popularity and IMDb rating and how it compares to the different genres. So one last data prep step that we had to do, similar to the actor column. If I scroll down here, genre also had multiple entries, multiple values in it. So we had to basically parse and blow that out as well. And you see that in genre 1, genre 2, and genre 3, each genre representing its own value, basically. So the first question that we wanted to answer was, what genre of films share the highest percentage present in the selected top movies? And to get the percentages, we first had to get the counts of each genre. So we had to get the counts of each genre in the genre 1 column, genre 2, genre 3. And after we got all the counts, we basically summed all those up using the group by method. And then lastly, we created a new column called percentage, which basically just calculates the percentage. So this is what the final table looks like for that information that we're looking for. We have genre, the number of films a part of that genre, and then the percentage compared to the total number of movies. And this is just a simple bar chart, kind of providing a better visual. We have the x-axis representing genre, the y-axis representing number of films, and then percentage is on top of each individual bar here. Our top genres are drama, adventure, and action. Not too surprising there. I think those are pretty popular with the public, and I would consider those catch-all genres too. I think a lot of movies can be labeled those three. And then the bottom genres were film noir, Western, music, and history. The second question that we wanted to answer was, what genre films have the highest IMDb ratings? So similar process, we had to get sums of all the ratings for each genre, for each column, genre 1, genre 2, and genre 3. And then from here, we have all the sums, but we needed to group all those sums together. We did that by the group by method, grouping by genre, and then getting the total sum. And then finally, adding a new column for the IMDb rating average, which essentially represents the rating average for each genre. And this is what the data frame looks like after we did all those steps. We had to combine a couple data frames here. We combined the initial data frame with this new one that we gathered around the rating sum. You see count and percentage, which came from the original data frame, and then our new columns, rating sum and rating average. So if we just take a look at an example, if we take a look at the first record for the genre sports, the total ratings for all the sports films was 16.2. The number of films for sport was 2. 16.2 divided by 2 is 8.1, and that's how we got our average for each genre here. And this bar chart here does a better job of providing the visual of kind of what the data is showing us here. We went with a gradient color scheme for this chart because the variation of colors in the previous chart just didn't do a good job of visualization and helping us interpret what was going on. I think that's just because the bars were so close to each other. The difference is only like 0.5. But if we take a look at the chart, what's interesting is the genres that represented the lowest counts actually have the highest ratings. So Western, history, and film noir were all at the bottom tier in terms of counts, but have the highest ratings. And just the genres that had the top counts were adventure, drama, and action. In terms of ratings, they're kind of just spread in the middle. So probably a reflection of just there being a small sample size for these ones at the top of the chart. A secondary chart that may have been good would have been to compare the counts to the ratings to kind of see if there was a relationship or distribution there, but maybe a task for a different time. And then last question we wanted answered was around actors. We wanted to see the top actors in terms of number of film appearances. And this bar chart here, we have the x-axis, which is actor. The y-axis is number of film appearances. We went with a gradient color scheme with this chart as well, but something a little bit different is that each bar represents a different color, each bar height. So for example, all actors that had 2 film appearances had the same color bar. All actors that have 3 film appearances had the same color bar, so on and so forth. And the top actors that we see here with the most film appearances were Leonardo DiCaprio, Harrison Ford, Tom Hanks, and Robert De Niro. All very good actors and all not surprising that they're on this list. And that concludes the data analysis portion.
Cool. Okay. I was just waiting to see. I was like, is that it? I don't know. It's always that moment. So very cool. We've got a couple of questions and a couple of comments in our YouTube channel. One being that it looks like user Kadeja loves Alfonso. So if that's a friend of yours, there you go. And also wants to know what is the explode method that you guys were talking about?
Yeah, so the explode method basically takes here, I'm going to share my screen actually to better explain it.
While you're sharing your screen, I want to give a shout out to Jasmine. Hi, Jasmine. Jasmine Wynn is also in the chat, and she is also a TripleTen student, and she wants to make sure to shout out Deb and Monty's Data Circus. So, oh, and then Beth is shouting out Multiverse. Multiverse hasn't even gone yet. Okay, now you're sharing. Go ahead, Ryan.
Yeah, so if I scroll up to where we see explode, here we go. Yeah, so here's an example where we use the explode method. So we used string split here. If we take a look at the first record here as an example. So what string split did is basically took a look at each comma for this record and made a separate, I guess, value or entity for each one of these. So Tim Robbins separated it into its own entity, Morgan Freeman and Bob Gunton. And what the explode method does from there, it basically creates a new row for each one of those values. So we wanted to do that because, again, we wanted to treat each actor as its own individual, I guess, line item. And so I guess in summary, to answer your question, explode just basically creates a new row for each one of the values that we created.
So it takes the values and makes a new row in your data set, in your your database that you're pulling from.
That's correct. Yep.
So if it's like an Excel, it'd be like a comma separated value.
Yeah, that's exactly right. That's a good comparison. Yeah.
All right. Well, Kadeja and I have both learned something new. All right. Fantastic news. All right. Let's talk. Another question that I had was just kind of looking at the visualizations. You guys talked quite a bit about the data that you pulled. And I know Robin had mentioned that he went through and just kind of named those 100. And so I was curious about kind of, again, the thought process around, you pull the 100 and you just kind of pick those versus trying to get the meatiest, juiciest little morsels of questions that you guys could. So tell me about how that worked for your team.
Yeah, Robin, do you mind answering that question if you don't mind, since I think that list came from you.
Yeah, so after I actually explored and looked went on the website and actually looked at the top 200 and I think 50 I think it was. These were kind of like top of the list, and a lot of these were kind of my own favorite films because I've literally watched every one of these films.
You were probably with me in the theater for the 1924 film.
Yeah, probably. One of my favorite movies on here is it's called the crazy one that went over I forget what the whole movie name is. Where'd
But
it
you
go?
picked the top 100.
Yes, and then pretty much with all their ratings, pretty much it being the top ones, it was kind of easy to kind of get the information that we needed from them.
Mhm.
I mean, other than that, we just put them. It's easier for the database to or the web scraper to go through and get the information for specific things instead of having to search the whole website for these.
Okay. Okay.
And not just that, I wanted to do it in a long form because when I did this, I was a little bit bored at work doing this, so I wanted to kind of do it the longer way.
All right. So then, Ryan, tell us about how you guys arrived at these questions on how you took the different bits and pieces Robin put together and decided as a team where to go from there.
Yeah, no, for sure. So when we were talking about what relationships and patterns and trends that we kind of wanted to pinpoint, we were bouncing ideas back and forth, and all of us kind of were saying the same things, interested about ratings and popularity and how genre specifically differed with those. So we were all kind of in agreement right off the bat that genre was the overarching thing that we kind of wanted to look at, and that kind of led to the questions that we answered in the presentation.
Cool. All right. Well, very excited to see all of the data that you pulled. I really do. I am partial, of course, to the multicolor bar chart that you guys had, but the gradients are also very nice. So, well done. So that is the Fuzzy Pandas, and that team again is Anthony Johnson, Ryan Modesset, Phil Zamazahir, and Robin Matthews. Thank you again. Okay, so now Beth, this is your chance to yell go multiverse. Okay, multiverse coders. That is our team that is up next. That's our last team for the evening. And that team is John Dwyer, Jill Fadu, and then Dino Falcao, and then Sohini Tamar.
Hey guys, Jill, do we have the presentation?
Yes, I'll just share right now.
Okay. All righty. Okay, so hello everyone. We are the Multiverse Coders, and our project assignment was web scraping the IMDb website for our list of movies and actors and performing analysis on those movies and actors and see what sort of information we can glean from our web scraping project. So we'll go to the next slide. So this is a basic overview of our project. As I said, we were going to use Beautiful Soup and other web scraping tools in order to collect data from IMDb. We were aiming to create two different data sets, one for movies and one for actors, each with 100 observations. So think 100 movies and 100 actors. And we broke that up into 4 different genres. That's how we decided how to prioritize our movie list. We chose 25 from horror, 25 from comedy, 25 from action, 25 from thriller. And we tried to make that distribution over time. I think we went back to the early 80s for our oldest movies. And then we tried to get an equal distribution across each decade all the way up to 2025. And then in these graphics here, we can see a nice visual of what our features include in each data set. So as I said, our number of movies in each genre and across each time span, they're in the first exhibit. We have a list of features in Exhibit 2. So things like names of the movie, release year, rating, duration, IMDb rating, popularity, award nominations, etc. And then the final exhibit is the list of features for our actor data set. And just for transparency, we pulled the actor data set from our movie data set. So in the sense, each actor in our actor data set was directly from our movies that we see in our movie data set. So that's all for this slide. We'll go to the next one, and I will turn it over.
Thank you so much, John. So for this project, we use Beautiful Soup to extract movie and actor data from IMDb website. Beautiful Soup is a library that parses HTML files to locate specific content using tags and attributes. What we did, we used a URL of specific genres, which John mentioned earlier, and then we created into two separate data frames for movies and actors so that we can use it for EDA. And down there, you can see some code snippets, which were from our project, which we did. Next slide, please. So for EDA, for movies, what we did, we changed the data types for certain columns like release year, IMDb rating. The reason being, later down the line, you will see that we did bar chart and Pearson correlation, and it was very important to change those data types. We removed currency symbols from like dollars, yen, and pound from estimated budget and gross worldwide column so that we can calculate return on investment. We dropped certain duration column and some duplicate rows. We did similar things for the actor data frames. We number of award nomination and award wins, we converted it into integer type, and then we filled it with 0 so that it will be easier for the scatter plot. It can provide efficient results. We'll pass it on to Dino now. Thank you so much.
Thanks, Ohini. So the first question we wanted to address was if there was a median return on movies, what was it, and how it's been evolving over time. So in order to explore this, so our sample was of 100 movies, and essentially what we did, we compared box office earnings compared to the estimated budgets. Those two were provided in the IMDb website. So first of all, overall, what we found out was that movies, they tend to make about 3 to 4 times their budgets. And in the middle chart here, the box plot chart, so if we put aside some of the outliers, we found out that comedy leads with an average return of 4.8 times their investment, followed by the horror movies at 3.4 times, action at 3.3 times, and thrillers at 3 times. It's also important to note here to keep in mind, right, that the returns, they do vary widely depending on the time frame that you're looking at or whether there's blockbusters or not in the sample, right? I think also another thing here that is interesting to look at on the right-hand side, the chart here shows that the industry median return that appears to be on a downward trend. In our case, we do believe that this could be due to rising production costs, impact of streaming services, or even changing consumer habits. Again, it's also important to know here that this insight is just based on a very small sample, and that the full picture of the industry might be a little bit different. Now I will turn it over to John.
Okay. Here we see our Pearson correlation matrix, excuse me, and we're trying to answer our key questions. What relationships exist between our different movie attributes and how are they influencing a movie's commercial success? Now, the Pearson correlation matrix, what it does is it takes our list of features that we have in our data set, in this specific case, the movie data set, and it gives us an idea of how they're related to each other. So a high correlation would mean that, one feature, say, for example, IMDb rating goes up, we would expect, if there was correlated to another feature, that feature would also go up. So we're getting a good idea of how our features are related here. And a couple of things that stand out immediately in our correlation matrix is a couple that are intuitive and a couple that are not so intuitive. The intuitive, for me anyway, is the budget and revenue relationship. As the budget for a movie goes up, we can expect to see an increase in gross revenue worldwide. That's sort of a good case for any movie producers out there who want to, seek investment. Hey, the more investment we get, the more we'll make on the back end. But what's surprising about our data as well is there are a couple not so intuitive relationships here. So for example, we have a weak correlation between popularity and critical rating. You'd expect that a popular movie would, be beloved by both critics and people, but it's not so much the case. In fact, we see a very weak correlation between movies that get a strong endorsement from critics and their popularity with viewers on IMDb. And as well, another not so intuitive thing that we see here is a moderate link between nominations for awards and financial success. So again, we'd expect to see, movies getting nominated for awards to be making a lot of money worldwide. And it's not so much the case. In fact, it has a rather small impact on whether or not a movie is commercially successful. Based on what we see here, a couple questions kind of pop up, like, for example, whether or not we need a larger data set. Are these correlations that we're seeing the result of the fact that we're only looking at 100 movies in our movie data set? So it could, in theory, have broader consequences if we expand the number of movies we're looking at. But for further analysis, I'd like to know why there's a weak correlation between IMDb ratings and gross revenue, and then also what factors might explain the negative correlation between popularity and award wins. And we'll go to the next slide.
Thank you, John. So our next question is, do actors with more credits or more nomination tend to win more awards? So for this, to analyze this question, we have done 3 different graphs. The first graph is award wins based on credit, which shows a weak positive correlation with a wide variation, which represent that there are some actors with many credits who have won numerous awards, others have not. This suggests that quality matters more than quantity. The second graph in the center is award wins based on the nomination, which shows a strong positive correlation indicating nomination boosts the chances of winning. Like the final graph, which compares previous both graphs, in which you guys can see the steeper slope of the nomination trend line. It's in orange color, and the gentle slope of the credit trend line, which is in black color, confirms that nomination predict wins better than credits. So lastly, coming to our conclusion, based on our analysis, we found that comedy movies has the highest ROI despite lower budgets, outperforming action movies. The industry's ROI has declined over the decades, which is due to rise of TV and streaming services. Higher IMDb ratings doesn't guarantee popularity, as storytelling, direction, and award matters. Nomination are key to winning awards, while more credit doesn't ensure success. However, our dataset was only of 100 movies and actors, which has limitations like small sample size, selection bias, incomplete representation of various genres, and actor career. So for future reference, one should use a larger database which would reflect the real world data. Thank you.
All right. That was very exciting. I had to laugh so hard whenever you guys were talking about the kind of the weak correlation or inverse correlation between the critical ratings and the popularity. I was just talking today to my Jedi mentor whose favorite movie is Howard the Duck. And if you haven't seen it, don't go watch it. It's terrible. You can just watch the clips. But it was just like terrible, terrible ratings. But it is a cult following where people still watch it 2 and 3 times a week. So yes, that is a real thing. I think you guys are pointing out in the data. So let's talk again. first question is definitely, how did you guys work together as a team in pulling together the questions for what you guys wanted to pull from that data that you pulled up?
So I'll like Dino to answer about first question, because that question he really thought about it. He was like prepared before we were looking at the data sets. So I'll like give it to him. And then second question was John's. Like I guess they already had it in their mind, and I'll talk about the last question.
All right.
Yeah, thanks. So regarding the questions, well, I think we all kind of worked together to come up with the questions. The one that I kind of came up with first maybe was the one regarding the return on investment, because as we were scraping the website, there were a couple of variables features that were not previously included in the project, and we thought that this would be interesting to have, which was the gross worldwide, the box office earnings, right, and the estimated budget. And by having those, we could have a better understanding of return on investment in terms of different genres, and also over time what is happening with the industry, right? So that was kind of the way that we approach it. And then the other questions was just, as we had the data and the data frame ready, look at the variables we just discussed, and then come up with the remaining two questions, right? But that was essentially it.
Yeah,
Right on, thanks.
And I can jump in for the second question, which essentially the correlation matrix came to me as an idea for, and we discussed it as a group. It's how do we make sense of these features that we're getting? How, and the next real question was, what kind of story do they tell? And I do think for me, the correlation matrix is just a really great visual to see, immediately what kind of features are linked to each other. You can get some pretty exciting results. And I think we all kind of looked at it with, raised eyebrows when we saw like, oh, so a company or a movie that's winning a lot of Oscars isn't necessarily making the studio a lot of money. I wonder why that is. And I think, it kind of opens the door to further discussion, and it kind of lights the way for, hey, where else do we want to take this research in case someone wants to come and look at our work and, try to answer those questions for themselves.
I love that. Yeah, really great questions that you guys came up with. In the little live chat here on the YouTube, Sohini has a relative of some kind that is very much shouting out Team Multiverse and has a wonderful question.
His friend, I guess.
Yes. So Manundra, it looks like Manundra has the question around, what was the most surprising finding for you?
I think IMDb rating. I was so surprised with the popularity and rating. We will always wonder, right? If it has high rating, it should be popular. So for us, that was very surprising. Why is the rating so low?
Yeah, I'd be curious too. Who is making these ratings?
I wonder. But I
Like
think
some
it depends
crotchety
what you
old
like.
dude sitting in the back? Like,
No, but
get off my lawn.
because of the critics and all that, there are different people like different genres and all that. So maybe that's why.
Yeah, very interesting. I think there's another question that Sam North in the chat wants to know. Any adjustment for inflation looking at budgets and box office? Great question, since you guys are looking at over time. I know you guys narrowed your time down quite a bit versus, Monty's Data Circus, which was looking all the way back to 1924. But great question about any adjustments around inflation.
Yeah, I mean, since we were looking just a ratio, right? I mean, this was kind of already implied from the data that we pulled, right? So we were pulling data directly from the website. So both gross and estimated budget, I guess it was already adjusted for inflation, because
Great.
wanted to avoid that if we just look at the number, the absolute number per se. So that's why we decided to do a ratio, right? So in that case, you would be protected from any kind of inflation or not adjust inflation in the numbers. Right?
All right, great question. All right, and then in terms of working together, this is a question that I like to ask a lot of teams, but first time I'm assuming you guys have worked together. How did that go, right? I know a lot of the coursework is kind of individual, but real life, the working place is working with people in these kind of remote settings. How was that experience for you?
So, we tried to meet, and our team members was really amazing. Whenever we planned it, they were there. We were messaging on Discord. Everyone will reply, and we are in different time zones. Mind me there.
Yeah, we all are all four are in different 4 time zones.
Yes.
Oh
So
my
we
goodness.
organize a team Zoom meeting, and we selected a time which works for everyone. So every day we'll go there. We will sit there for 1 or 2 hours, and then throughout the day they will work with all the presentation, all the other documents, and then we will give a timeline or target. Oh, tonight we need to finish our presentation. Tonight we need to finish our data frame. But our team, I am blessed to have team like this. They were amazing. Everyone did their part, so we don't have to hoggle anyone, or so
Yeah.
it worked really amazing.
I'll also jump in just to add a quick 2 cents. So I took my own attempt at the data scraping, and I was struggling with it a little bit, and I think that was a really positive thing for me to have a team, because I think it was Dino and the rest of the team came up with an idea, and immediately I was like, how did you do that? How did you approach this issue? And I think the four of us were all really excited to sort of come together and just learn a new way of doing it a little better. And like I said, I think as soon as that happened, I was really excited to just get everyone's input on everything, which is kind of a fun thing to realize about working with a team.
Yeah, it really
Oh,
is.
also,
And so you guys are all in different time zones, you said, yeah?
yes.
All right, Jill, what were you going to say?
I was going to just add that, like, while for web scraping too, we end up dividing, because we are 4 team members, each team members picked up just a random genre, and we end
Mm,
up picking different movies. So only one person does not have to pick all the movies. So that's how each of us is picking like 25 different movies, and then we focused on 25 actors. So that's how we came up to 100 and 100. So
I
that
like it.
teamwork really helped us.
Yeah, probably good that it was 4 different, like in terms of data, right? You're pulling from
Yes.
4 different perspectives.
Mm-hmm.
So fantastic. Great work. I really appreciate all of the work. Again, very popular in the chat. You got some votes in there, so that's always nice to see. All right, that is the Multiverse Coders. That is our last team of the evening, and those teammates are John Dwyer, Jill Fadu, and then Dino Falcao and Sohini Tamar. All right, so that is all for us tonight. So thank you again for everybody in the chat and for everybody watching. I love when the chat is so active. It is always so much fun to see what kind of questions you guys have as viewers, and see whose family members get to come watch. I know I love it when my mom comes and watches and then criticizes my hair the whole time. Top notch. So, all right, let's wrap up for tonight. Thank you again. This has been our February data science code pudding presentation. If you haven't voted yet and you are a student of ours, look out in the Discord for the poll that is going to be asking for your vote. If you're not a student of ours yet and you're just a friend and a family member watching, please go ahead and make sure that you tally your vote down in the chat below. And then the results and the winners are going to be announced February 19th in our Discord and our socials. Thank you guys so very much. And thanks to all of our behind the scenes people that make all of this magic happen. So I just want to shout out Daniel, Camilo, Natasha, Elena, Olivia, Ilya, Anastasia, Nadia, and of course, my cat Shark Bait, who's really, really the one holding it all down. Thank you again to all of the participants, all of the teams tonight. You guys really just did an amazing job. Again, knowing that it is a short time frame and we have asked you guys a very open-ended project, you guys came up with some amazing data, but then also some amazing polls and meanings. And it was just really great to see all of that hard work. Thank you again for your courage. It takes a lot of courage and bravery to come out here and show everybody your hard work. So thank you for that. My name is Tiffany Hall. You can find me at Tiffany Codes on Instagram, and you can probably find my cat Sharkbait teaching a masterclass on the art of looking unimpressed. Thanks so much and have a great evening.
Thank you so much.
Bye.